So let's prove the following. So here we have two types of product. We have a scalar product and a vector product. So we have a scalar product between A cross B and B cross C cross A. And within this parentheses, we have a vector product. So this is a vector product of four vectors. We will begin with the left hand side, but with the vector product of four vectors. But before that, let's try to review how to find the vector product of four vectors. Let's say we have vector A cross B cross product with C cross D. Then this can be also represented as, we'll start with this vector, the third vector. If we read from left to right, we'll take the vector C and simply multiply it to, there will be no cross or dot product. It's a simple multiplication to a scalar product of the remaining three vectors. Now there's a sequence to reading this vector. So right after C, we have the vector D. So we will consider the vector D. Then we'll come back again to the beginning, and then we are left with A followed by B minus, now we'll consider vector D, and this will be multiplied, a simple multiplication to a scalar product of the remaining vectors. Since we are starting with D, so we'll come back to the beginning. Now we are left with A, B, C. We'll read from left to right. So we have A, B, C. So this is how we can express the vector product of four vectors in this particular fashion, where we have now only scalar triple product. So let's begin. So that means we have B cross C cross C cross A. This will be, so we'll start with this particular vector. So this is C vector. This will be simply multiplied to the scalar triple product of the remaining vectors. So right after C, we have vector A. Then again, we'll come back to the beginning. So we have B followed by vector C minus, then we'll consider vector A multiplied to the scalar triple product of the remaining three vectors. So we started out with A, we'll come back to the beginning of the sequence. So we have B, then vector C, followed by the remaining vector C. Now by definition, this scalar triple product between B, C, C, this will go to 0 because we have two vectors that are exactly the equal. So this will go to 0. So that means our vector now is C vector multiplied to vector A, B, C. So let's call it C vector multiplied to this scalar vector. Let's call it alpha for the time being, where alpha is equals to the scalar triple product between A, B, and C. Fine. Now we come back to our original vector. So we have vector A cross B. So this vector is dotted with this vector B cross C cross C cross A, which you obtained just now is C vector times alpha. So we have A vector cross B vector dot C vector. This by definition is the scalar triple product between A, B, and C. So that means this is also alpha. So this will be alpha, and we also have a alpha. So alpha multiplied to alpha is simply alpha squared, and let's finally replace the value of alpha. So this is A, B, C squared. And this by definition, we can also write it down as vector A dotted with the cross product between B and C, and then we take the square of it. This is going to give us the right hand side.